Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is our 21st episode on Gödel, Escher, Bach by Douglas Hofstadter.
Hey, John, how are you doing?
How is it going?
I am doing all right. We've got kind of a special couple of episodes to end our saga.
Definitely a saga. Yeah, this book has been absolutely epic, but we are wrapping it up. We're kind of tired of recording episodes about this book, but it was an awesome book, incredible book.
Yeah, we didn't really look before we leaped, I guess I would say.
Yep.
That's life, but we stuck through it.
We did.
Much to the chagrin of our listeners, I am sure.
Yes, this is more a testament to our stick-to-itiveness and not a testament to the material being good.
Right. No, we never let quality get in the way of pig-headedness, I guess I would say.
Could not be more true. But this book did, it was, as the rest of the material was, like the last few chapters were very interesting. He got into a discussion on state-of-the-art AI at the time. This is like late 70s, which I thought was fascinating. We'll talk about it a little later. But I guess this chapter was more about... This chapter was interesting. It was like a little bit philosophical. My take on this chapter was it's about how thinking can be viewed as a high-level description of a system which on a low level is governed by simple, like almost, I want to say like obvious rules. The brain does all these computations, basically, both physical, chemistry, electricity moving through the brain and DNA using chemistry to, do the programming of the human body. That's all very low level understandable rules. Thinking itself, like abstract thinking, is sort of a high-level description of those vast, low-level rules.
Right. And in particular, I mean, the reason why we're talking all about this is he talks a bunch about the Church-Turing thesis, which my understanding is that this is kind of fundamentally the Turing-complete equivalency, essentially. That anything that is Turing-complete is isomorphic with anything else that's Turing complete.
Right. Like they all have the halting problem and
they all have the halting problem. But I mean, and I think what Hofstadter is saying here is that human thought processes also Turing complete and therefore could be isomorphic with a computer that comes up with the same result that a human does.
Yes. Yeah, and he has a hilarious example later in the chapter where he talks about deciding between a cheeseburger and a pineapple burger.
Yeah. Yes.
And I actually really like this example because he mentions how when that type of indecision happens, it's not as though your brain is running slowly. Like your neurons are firing at the same rate at all times, no matter what. It's some higher level thing that's happening, throughout your life. You've established these weird neuroses, which this really speaks to me, by the way. And those weird neuroses that have developed in your brain structure over years of, removing glia and creating your brain's larger structure have caused you to have this indecision between cheeseburgers and pineapples.
Oh, I have experienced this so acutely because it's funny because from your subjective experience, your brain's not working. There's no processing going on in your brain, and that's why it feels like the program it stopped.
Yep.
And I experienced the most acute visceral experience I've had recently is you are called on by a professor, so in law school, one core element to this is the cold call where they just randomly pick your name from a list and they're like, what's the answer to this question? And so, and man, like, you talk about your brain just like going completely blank, even though if it weren't so high stakes, like you would be able to answer it easily.
Yeah.
It's like your mind just goes blank, and it's like, I don't know. And that's almost a more unusual situation than what he's describing. Maybe not unusual, but there's a question of like, what is different about that scenario? Like, why is your brain deciding to do something different in that scenario than if your friend asked you the same question?
Yeah. Yep. And it's strange. Well, I don't want to go on a massive tangent, but I think about this a lot where we put so much of a premium on that, like, in the moment execution. Like sports is a perfect example of this, where sports is all about like, can you do the thing in the moment?
Yeah.
And I just feel like humans are so much better at doing the thing not in the moment.
Yes.
that I've always thought it was just very interesting to me that we put so much of a premium on doing the thing in the moment.
I think it's the I don't think most people would call this out, but I think it's kind of the. Have you heard of p hacking?
Oh yeah, yeah. I have a friend who, like, is kind of part of the science industrial machine, and he complains a lot about p hacking.
Right, which p hacking. My understanding of p hacking is you just do an experiment enough times until you get what seems like a statistically significant result, but you just did it so many times that like. Eventually, it's like, yeah, this is a 95% confidence, but you did the experiment 20 times. So it's like,
yes. Yeah. I feel like
expected.
I think that is like explicitly what p hacking is, but I've heard people use it almost to define just being disingenuous with data. Mm-hmm. Like, I feel like the term has sort of taken on this like more abstract meaning. Because I've also heard it used to describe a lot of what sociological science does, where they just take a specific demographic and they run an experiment. And it's like, oh, this thing worked really well in this very specific demographic. And it's like, well, that's clearly not that useful to the entire human race.
Right. But they try to spin it so that it's this massive discovery. And
exactly. Yeah.
But anyway, getting back to sports, I think the idea is if you're just doing it by yourself, you could try 10,000 times and tell people about the one time that it actually worked.
Right.
But anyway, so getting back to the chapter.
Yeah, there was an interesting part. I love whenever anything brings up Ramanujan. I feel like Ramanujan is like a meme where whenever he's mentioned, it's always in the context of like someone talks to him about like a math thing. They'll be like, oh, I was in a taxi and the number was whatever. And then Ramanujan will immediately give this like extremely in-depth intuition / insight, into this math thing that he just comes up with on the spot. And anyway, so he gives an example of this in this chapter where evidently there was this problem about billeted officers and you had to solve this endless fraction. They didn't give enough detail on the problem for me to determine like what the actual problem was, but it's just an anecdote where Ramanujan came up with this like amazing solution for the problem, and he really impressed this other mathematician. But I'm really rambling here. The whole idea behind this was to describe how the way Ramanujan thought was, at least from observers who knew him well, not different from how other mathematicians think. Like, it's not like he was using some other set of rules in his brain to come up with new mathematical insight or to perform computations. He may have been much better than other mathematicians at those things, but he wasn't using like novel processes. And I guess the whole point here is there's this isomorph between him and other mathematicians. And I guess the argument is like, we're all sort of using the same underlying set of formal rules at the lowest level, but sometimes those ladder up to these different more amazing, higher level abilities.
Yeah, this is something that's interesting because if you're achieving a different result, like surely something must be like is he just saying they're using the same system? Like because those feel like two different.
I think he's saying they're using the same system. He mentions how there's no mystical thought process that could lead to, these crazy, astounding results that Ramanujan had that can't be put down in floop. Meaning, he was using the same set of underlying reasoning tools that every other mathematician had. He was finding new insights and doing crazy stuff. So there was clearly something special he was doing, but it wasn't as though he had some, unique tool chest.
One point that is unclear to me is like they talk about Turing. I don't know if is it in this chapter they talk about Turing's. I guess they go into the Turing test. So maybe if we're just blending it all together.
Yeah, I think that might have been the next chapter.
Yeah. So I mean, in the next chapter they talk about the Turing test, and Turing and Turing himself referred to it as the imitation game, where if a human wasn't able to determine whether he was talking with a human or a machine, then that machine is intelligent, or like that's one test.
They passed the test.
What it sounds like Hofstadter is saying is that if those two things are identical, like it's like those are isomorphic because they behave in the exact same way. But he's also attempting to argue that like no, like the actual underlying processes themselves are isomorphic as well. Which for math, I guess that feels like okay, fair. You're just using numerical operations. We're all using the same language to operate on. But it sounds like for language, that's a harder case to make, I guess, or maybe not.
Well, yeah, and I think that's one of the more interesting themes in this book. He discusses strange loops all the time, where you have these low-level processes which ladder up to higher level, consciousness or the sense of self or whatever. All these super high-level concepts, and I think maybe Hofstadter would argue that a computer. Let's take a large language model of today. They seem human. I think Hofstadter would argue that even though on some level, we're performing these biological chemistry processes, and computers are performing very electric silicon processes, but there is some level where we're very similar.
Yeah.
There's the same abstractions. And I think that's part of what I was taking away here, is, in spite of Ramanujan's sort of magic seeming leaps and intuitions, on some level, he's just like every other mathematician.
Yeah.
And actually, I'm glad you sort of started going into the next chapter, because I wanted to say a couple things about it. Maybe we can kind of transition to the next chapter.
Yeah, there was just one thing, one point that he raised, which I thought was just a good shower thought. He talks about beauty and whether or not it's intrinsic to the object itself.
Yeah.
Which, it's, I think when you talk about a beautiful object or a beautiful person, it sounds like it's attaching to the person or the object themselves. But you kind of realize beauty is really, and like it's so trite, but beauty is in the eye of the beholder.
Yep.
That's really true. It's like beauty, if a woman is beautiful in the forest and there's no one around to see her, like, is she actually beautiful? Like, no, I would argue it's there needs to be some other conscious being there to perceive the beauty in order for something to be beautiful.
Yeah. There's another book called Zen and the Art of Motorcycle Maintenance by Robert Pirsig, where he discusses beauty. He refers to it as quality often, but he describes it as this like culmination of, deep skill, talent, symmetry. It sort of felt like this thing that could be put into words. Like, even though beauty is this totally like ineffable thing, there are elements, like an artist. You look at the Sistine Chapel and it's clear that it requires such deep skill that can only be learned, through a lifetime of doing this. And I think when you're seeing the beauty of the Sistine Chapel, you're seeing that skill. You're like perceiving that only, a lifetime of like work and talent could yield something like this. I think that's at least part of it.
So it almost sounds like you're taking the other side of that argument, that there is something intrinsic to the object that.
I think so. Like when you're seeing a beautiful person, you're seeing, hard work in the gym, or you're seeing really good genes, or, you're seeing symmetry or something. I don't think I'm taking the other side, because I do think there is definitely an element of beauty where it can just arise out of nowhere, and and it is very cultural. But I also think there's another interesting element to beauty that is very quantitative.
It's like, why is a sunrise beautiful?
I think that humans have an innate connection to nature, and things in nature that are, without sounding silly, I'm going to definitely sound silly here,
Dude,
but
silly it up.
like, I think, humans like rainbows, because rainbows are this crazy visual phenomenon that happens. Like, I was at Niagara Falls recently, and you can see all these circular rainbows.
Yeah.
And it was just like, this is crazy. This is amazing. But yeah, it's just physics, right? It's just like light passing through little droplets in the air. So there's nothing.
I have a theory, which is we experience beauty, like from an evolutionary perspective. Beauty is a way to encourage us to explore. I think we are rewarded when we see things that we've never seen before. And that takes the form, like if you're at the top of a mountain, you're like, damn, like I never see this. Like this, I don't see this specific combination of my neurons like going crazy.
Yeah.
And like that made you climb up or like made you want to climb up to the top of that mountain or get over that hill or this, that, or the other thing. Like, that's my current working theory for why we would develop that like subjective reward for nice looking things.
Dude, I think that you're hitting on something. I think this is why humans have achieved what we've achieved, because we strive for beauty and quality. Like we find those things to have value, and things that aren't beautiful don't have value. So we move away from them and discard them. And I think that's been such an important part of our ability to progress.
Yeah. All right, but I kind of halted your transition to chapter 18. Let's soldier on.
No, that was a really good interlude. But yeah, chapter 18, the dialogue in this chapter was super interesting. He's talking about this thing called Sherdlu.
Yeah.
Which, did I just like skip over what Sherdlu means? I didn't.
No, he talks about it at the end of this chapter. So Etoan Sherdlu is a phrase that comes from typesetters, where they would keep all of their letters in rough order of their frequency. So Etoan Sherdlu is like roughly the frequency that typesetters would need to use those letters, because they would just keep them in that order so that it was quicker to actually typeset something.
Nice. Hilarious.
So, but anyway, he took Sherdlu from this, like the second part of this, of that phrase.
Okay. I had written down in my notes, is this an acronym? ? So I guess I never figured that out. But yeah, the dialogue was all about this. It was like a computer program where you had this set of blocks, geometric blocks like cones, cubes, spheres, and you could tell the program, like, move the sphere on top of the cube, and it would like perform that action for you. And then you could query stuff about the state of the objects, and it would sort of tell you you're, taking crazy pills. Like if you said, "Oh, is the pyramid on the cube?" and it wasn't on the cube, it would be like, "No." Or if you asked it a nonsense question, it could sometimes tell that it was a nonsense question. And I was kind of laughing while reading this dialogue because I was like, is this what was considered state of the art AI like at the time of this writing? Because it just seemed like such a quaint like utility. And these days, you can pass some hyper detailed image to an AI and it will describe it in like a huge paragraph.
Dude,
like
I cannot wait until we have house robots.
Oh, dude, it's going to be huge.
I think we're right there. I think, like, I would say by the end of 2026, there will be a reputable company that you can buy a house, like a robot that would be able to fold the laundry, wash the dishes, tidy up.
Yep. I think my theory, and I would, like, buy robotics ETFs because robot is going to become the next big purchase. People have house, car, phone, TV, a couple other whatever appliances. Robot is going to be like right there under car.
It'll just be like the last appliance that you buy.
Yeah, exactly. Well, it's kind of the appliance to end all appliances.
But it's like first you buy the dishwasher. But then once you have the dishwasher, like if you have more disposable income, it's like, of course, I'm going to buy a robot that can load it so that I don't need to. I mean, although it's interesting because do you even need a dishwasher?
That's what I was going to say. It's like, I think I think you actually buy the robot first.
Oh.
Because the robot can just manually wash dishes. And you don't care if it takes him 6 hours.
Yeah. I have heard that dishwashers are more efficient though than washing them by hand. Though, so,
yeah. But in any case, that was sort of my takeaway from this dialogue is just how quaint it was. He starts the chapter with a brief description of Alan Turing. Mm-hmm. This sort of was right before his description of the Imitation Game. Mm-hmm. And he mentioned that Alan Turing died from a, quote, accident with chemicals.
Oh, God.
Which I was just like, are you kidding me, Douglas? Like, Alan Turing committed suicide because he was chemically castrated.
Right.
Which Douglas makes no mention of Alan Turing being gay or, him undergoing extreme torture, basically.
Yeah.
By the U.S. government.
By the government. Well, it was the UK government, right?
Or by the UK government after he had contributed so greatly to the UK government and our war efforts, which is, this is one of the great tragedies of the modern age, Alan Turing. And I felt like, not that I need every mention of Alan Turing to be this like full story or whatnot, but I just felt like Douglas Hofstadter's description of Alan Turing was so I don't know if like whitewashed is the right term, but it was just very like, it was like light reading. It's
almost like it would be better just not to reference his death at all, like rather than just oh yeah. They do say some say suicide, but
it just felt like a massive cop-out to me. Like he was specifically trying to avoid mentioning...
Yeah, there's such important context there that it's a dereliction of his responsibility as an author to like not... Like if you're going to bring that up.
Yeah.
And he was only 41. That's the other... Like, that's the mind-blowing thing. Imagine. Like, this is really a crime against humanity. Because you have one of the most absolutely genius people of all time.
Yeah. It working in, the most important technology of our era, furthering our, our knowledge of computing.
He could still be alive today.
Yeah.
Like, this book was only written this was written in what, well, no, wait. No, he couldn't. He probably couldn't be alive today. But
he couldn't. Yeah, he would be in middle age around World War too. So yeah, probably dead by now.
Yeah, no, I was thinking he was 41 at the time this book was written, and so no, but anyway, if you've never seen Imitation Game, I cried at that movie because it talks about all that stuff and just the injustice of the whole thing.
I just like Keira Knightley. I'll watch anything with Keira Knightley.
Oh, nice. I didn't even really. I just remember that I was like just demolished by all of the like. When you watch the movie and like they have those like those like credits at or the like where are they now, or like those little title cards that describe like actually what happened after the contents of the movie.
Yeah,
dude, those are my kryptonite. Like those just always like just get me.
Dude, have you ever seen Stand By Me?
No, but now it sounds like I'm gonna have a new way to just, I don't know, chop some onions.
If those are your kryptonite, by the way, my dog is freaking out in the background. It's probably audible, but if those, where are they now things are your kryptonite, you should check out Stand By Me.
Nice.
It's a good. It's also a great movie. It had like, early River. I want to say River Phoenix. I think Kiefer Sutherland might have played one of the kids. Like all these super famous actors basically play these little kids in the film, and it's based on a Stephen King book. A really good movie.
But anyway, so he did Turing dirty in his description.
Yep. But anyway, this chapter felt to me like kind of a description of state-of-the-art AI. So to me, this chapter felt extremely dated. You know, he discussed chess AIs. He gave kind of a discussion of like the Minimax algorithm.
Yes. I'm so glad you brought this up because I have Minimax in my notes.
Yeah. It's like he described how Minimax works. I don't think he ever named Minimax.
It might not have even been referred to Minimax at this point.
Yeah. But that was Minimax was a massive discovery in AI, or discovery. I don't know if that's the right word for it. But essentially that's the algorithm where you build a massive state space. Like in chess, you can only make so many legal moves on any given, board state. And so you build a huge tree out of every single possible move you could make. And then you use a heuristic function to kind of score those. And each player assumes that the other player will always make his best move. So that's why it's called Minimax, because on one layer of the tree, you're minimizing, because if it's black's move, you want to pick like the lowest scored move. If it's white's move, you want to pick the highest scored move. And this is chess, by the way. That's why I'm saying black and white. But anyway, that's why it's called Minimax. Right,
and the point that he calls out with Minimax is some approaches literally just search the whole. They just walk down the whole tree and they kind of try to find good end states without attempting to evaluate. And then other ones were just being like, okay, well, we're just going to look right at the board and just like look at like evaluate, do static evaluations.
Yes.
And the problem with the first one is just in chess, there's that explosion of possible future states is just too large to do in a reasonable amount of time. So that's when you use that like heuristic to kind of like prune the tree.
Right. Yeah, and there's a ton of, variations of Minimax. Like I don't think any real AIs use Minimax today. Something like Stockfish, which is probably the most advanced chess AI, uses probably an algorithm more like A-star, which is a version of Minimax that performs significant pruning, like you were saying, based on that heuristic function. And also, the more advanced that heuristic function is, the better your AI is. Although, one issue is it can prevent you going deeper on certain trees, which can also be a problem.
So
there's a trade-off. But anyway, another thing that he mentioned that I thought was interesting is he mentioned this guy who wrote this tool that basically transitioned from one piece of music to another piece of music, like it like interpolated between the two, I guess.
Yeah, I didn't know at what level it did the interpolation. I'm assuming it wasn't just a fade. Like, I'm sure they could have, before that time, they could just fade two pieces of music. I guess they, like, did it at the note level, though.
Yeah, it struck me as some sort of, like, MIDI,
Yes.
interpolation. And I don't know, it was just, like, a funny section because he was like, it sounded like crap. But it was very interesting. And one of his key questions is like, who's actually composing the music? Like, if you pick a slice out of the center of that thing, it doesn't sound like either of the pieces. It sounds like a wholly unique, bad piece of music. And his question is like, who's composing that? Like, is the computer composing that?
Right. And I mean, this is so much more relevant today because, like, if you had to ask who wrote a piece of code today, it's like, and you hear these estimates that's like 50% of code is going to be written by machines, XYZ. It's like, it's probably already there.
Yeah.
Because at least when I'm coding, so much, like, especially all of the kind of like ministerial, like the very, okay, it's like, okay, there's a function, there's very clear parameters in the local context, and then I just need to construct a call to that function. Like, that's the sort of thing that AI just like, it's just so easy for it to do. Of course, I'm constantly burned by it, like, guessing wrong about like which parameter should be, and then like I never chose which parameter should go into that function. It just picked something that, like, it just shape matched the function call. So of course I go back and it's not working, and I'm like, oh shit, like that's completely the wrong thing that should be in there. So but anyway, like the larger point is there is this question about like authorship in that context, because so much of it was done by AI, but the human is also in the loop there. So it's really a collaboration.
Yeah, no, it totally. People have been talking a lot about vibe coding, which I almost want to say the myth of vibe coding, because, I've been programming my whole life. I would say that AIs are extremely good at programming, almost insanely good, but they can't do the whole thing. Not even close. So it still requires this sort of human intervention to, prevent mistakes, but also to do like very structural things. And I think it'll go away. I think very soon AIs will be able to do the whole thing. But I just think there's a little bit of ways to go before that happens.
The thing that has, and I know we've talked about this offline, the thing that has blown my mind is now you can have an AI take screenshots of a web app. So you ask it to perform a task, and then it can actually interact with a web app. And that feels like the sort of thing where now it's closing the loop. It's able to validate its work. So who knows if you'll be able to, and this is something I need to try. If you have a simple app, an existing simple app, you ask it to add some unit of functionality. Can it do that? Well, we'll see.
Yeah. Yeah. And I think I don't know how much we want to discuss how capable our AI is at programming, but I think there's always, or not always, but in the relatively near future, there's going to be this effect where AI can get like 95% of the way, but that additional 5% is like insanely hard because you have to interpret what the AI did, and then you have to do the human element. Like the AI can probably code up a perfect app that clicks on, or you click on buttons and very specific things happen. But then, like, making that app feel good, like, do you add animations? Do you make, the flash on the button click take a certain amount of time? Like, there's just going to be this kind of long tail of, like, figuring stuff out.
Yeah.
And And I don't know. I mean, I'm a huge AI believer. I feel like I'm sounding like a AI skeptic, but I just see these things in the media that sound so sweeping, and having dealt with it on an almost daily basis, like it's not there yet.
Yeah. So we're not. All your programmers out there, don't get too worried that you're just gonna lose your job immediately. But
yeah, you might lose half your pay.
Yes.
And you might get replaced by the guy sitting next to you who's better.
The vibe coder next door.
Yeah, exactly.
So one of the themes that he talks a lot about in this chapter is creativity. And it's like, when can a machine be said to have been creative? And I know you're talking about this, but it's like, now the question becomes like, is the computer itself being creative, and to what extent is that an evidence of intelligence? And that got me thinking about, have you heard of like Move 37 in Lee Sedol's Go game?
No, I don't think so. Move
so
37.
this is this like famous move, basically. So Lee Sedol, famous Go player, or like the top ranked Go player at the time. This was in 2016. Google's DeepMind, they had AlphaGo, and they had 5 matches, and AlphaGo won 4 out of the 5. But there was one move in the second game, it was Move 37, which all of the commentators were like, no human would have ever thought to play that move. But it was this beautiful, and like apparently Lee Sedol took an unusually long amount of time to respond. So we're there, like we're really there. Where, I mean, obviously all of the stuff that's happened since, but like that feels like the kind of thing where there's like a flash of intuition.
Yeah, interesting. Yeah, you hear about this all the time in chess. There's actually like commentators refer to them as human moves versus, computer moves, where Stockfish will recommend these moves and commentators will almost like dismiss them. They'll be like, oh, that's a computer move. Like no human would ever, come up with that. And it's usually the type of move where like, I don't know how. So in chess, there's a concept of forcing moves where for a long string of moves, there's only one option. Like if your king is in check or something, it's like you have to get your king out of check. So, generally speaking, there's a limited number of moves, often only one,
right,
that you can make. And so the tree, even though it can be really deep, if it's all forcing moves, then a very good chess player can see deep into the tree because they're just calculating, single moves. But there's also these times where, and the positions are called sharp, where there's a lot of different moves. Very few of them are good. And many of them, even though they may look good, are actually really bad. And I feel like these computer moves arise out of those, mysterious positions where, there's a lot of possible moves that can be made. A lot of them might look good to a human, but very deep in the tree, some of those moves are kind of proven wrong. But no, even the best, even Magnus Carlsen can't calculate like even, 10 moves in the future if the set of moves is very, very wide.
Right.
Like he can only calculate that deep if it's like a lot of forcing moves.
In a way, I mean, those seem like the ideal move to make, where you find a move, like, so let's say you had one that was one move that started a chain of only one option moves, and then another one had this like these large expanse of like pitfall moves that are like available. It seems like that second one would be preferable.
Oh yeah, well, and that's what a lot of players. Mikhail Tal is famous for not necessarily making the best moves, but making moves that caused his opponent to be just completely thrown off.
Yeah.
And that's part of the reason why I think chess is still very interesting to people, is because there is a psychological component, a strong psychological component. And, a lot of times a move that's demonstrably worse based on a chess AI is actually the better move to play because of how the human reacts to it.
Yes. Which I was just looking up the games that have been quote unquote solved. And, because now I guess chess would be considered to be solved, right? Or is it considered to be solved, or?
I don't think it's solved in the sense of like everything is fully calculated. There's a thing called a table base in chess, which I think that if there's only 7 pieces on the board, every possible 7-piece combination has been solved. But, in the early game, there's 32 pieces on the board.
Right.
So I don't think it's been quote unquote solved. Every chess AI is like 10 times better than any human.
Right.
So it's solved in that regard. Like no human could possibly beat a chess AI.
Right. Okay. Well, so ultimately the games that I was trying to find, like, what's the frontier of games? And then a lot of people were saying like games where there's human interaction, like games that rely on psychology are the ones that still kind of remain to be solved. So
yeah.
But I think that's pretty much all I had. I don't know. Did you have anything else you wanted to?
Yeah, I had one more point, and I just want to mention this because it really segues into basically the rest of the book. He mentions how a primary problem in AI is how do you represent knowledge?
Yes.
And he discusses, a few different ways, kind of at a high level. He's like, is knowledge just a list of facts? Like, is it some like list of relationships between things? Like high is, conceptually above low, for instance. I mean, often it's literally above low, but it can also be more metaphorically above low. Mm-hmm. And so, yeah, he just does a brief discussion of like, how do we represent knowledge? How do we represent the relationships between like nodes of knowledge? And it's interesting. Maybe we'll do this in the next episode, but just comparing and contrasting it with how large language models actually represent knowledge.
Exactly.
Because there's some, again, like Douglas Hofstadter just makes these very prescient predictions. Sometimes he sounds, like he's making cave paintings, but other times he just sounds like he's from the 28th century. And it's kind of wild. But anyway, that's to come.
Yeah, this is still going to be. This is still a big problem today. But it's the one thing I'll say, and I don't want to get off onto a big tangent, is like this is a problem for humans too, right? It's not like sometimes it sounds like people are, or in my opinion, people are holding AI to a higher standard than you would hold a human to, basically.
Yeah.
And you want this thing to be completely infallible. And it's not clear to me why we would expect the AI to arrive at a more pure version of the truth than a human would.
Yeah. No, that's I see that a lot as well, and it cracks me up. I still find it, AIs are just so utterly advanced. Like, we are already living science fiction.
Yeah.
And everyone's like, meh, DeepSeek is better. Like, I don't know. It's just funny, all this quibbling when we're dealing with, like, just such extraordinary things.
Yeah. People have just started to take it for granted and be like, well, what have you done for me lately?
Yeah.
So,
yep.
All right, let's leave it there. This is a fascinating topic, but we'll have to explore it in the next episode when we cover chapters 19 and 20.
Heck yeah.
All right. See you next time.
See you, Matt.